So we're going to do more practice on file reading. Specifically today we are going to work with the CSV file, so that will give you plenty of practice for working with the CSV file in your lab, right? So you should have gotten, I sent out an announcement about a half an hour ago. If you can't see it, so check your email, and if you don't see the email, just go to Canvas. Either go to Canvas or to your email to get the file, but if you go to Canvas, you can find it by going to Introduction, clicking on Announcements, and then 314 file, which is the Pokemon.csv file, which I got, and it has a link to where I got it from, but you can download that file because I figured it was easier to tell you to just give you a direct link to download it rather than trying to get you to download something from GitHub. So just simply download that file, save it where you're going to, and that's an important thing. Remember what we learned yesterday. For these files, you need to save it where it is going to be working. So in the case of, so here, right, I put it on my desktop because I plan on making a file on my desktop, but I could easily just simply move it somewhere else. Say to desktop, documents, GitHub. Let's go to Classroom. Intro. And I could move the file to wherever I keep my code. Here I'm going to put it in. Yeah, I'll go ahead and move it there. So I'm going to go ahead and put it in the folder I'm going to be working in. And I'm going to go ahead and I will open up idle. Just to get to work on it. So here, again, I've put it in my folder. It's over here in just in my documents under a bunch of folders. Again, the Pokemon.csv, you want to put that wherever you're going to be working. I put it where I'm going to be working. Okay. And now, when I create a new script in idle, I'll just simply save this file. Save it as maybe, and let's see. First I have to go to desktop. Not desktop, but go to the same place, which was for me, which was going to Documents, GitHub, Classroom, Intro. So again, I go to the same place and I just give it a name. Maybe I'm going to call it just Pokemon Reading, and then there we go. Again, over here you'll see the path on top, and that should match wherever you want to go with that. If in doubt and you're working in idle, you can just simply try doing the open dialog, right? Which will by default will open where you're currently saved. It's going to be looking at opening a Python file. You can go and say, I'd like to look for a text file. And if you don't see, not text file, but CSV, but you'll be looking for a CSV file. So you'll hit all files. So go from Python to all files. And if you can't see the CSV file in there as well, then things are going to go wrong. Again, these things have to match where they are. To test it, right, what we do is we say open, and then I'm going to go Pokemon.csv. And then, okay, and as long as you get no errors, then everything's good. But if you get an error like this, if you get an error like this, you run it, and it says file not found, it means you put them in the wrong place. Make sense? So again, if it's not working, it's because you've downloaded them into the wrong place. Is anybody having issues that are occurring from not downloading it in the wrong into the correct place? The only thing I can think of is like Safari giving you an access denied to the file. If that's the case, try a different web browser than Safari. That's the easiest fix I have. All right. So, for those of you who are not aware about Pokemon, let me just simply briefly let you know about that. List of highest grossing, not films, but media franchises. Let's go to Wikipedia. By franchise, Pokemon's at the top. Pokemon is the highest grossing media franchise of all time. Nothing else comes close in terms of franchises. Mickey Mouse and Friends is worth $52 billion, and Pokemon is around $88 billion in revenue. From most of it from merchandising, a bit of jet aircraft livery, I guess. Some from their, from Pokemon Go and their other mobile games. Some from, films and stuff. Surprisingly, very little from the. Does licensed merchandise count the? Does that count the video games itself? And I mean, it doesn't count the TCG game, the trading card game. So I'm very curious as to how that actually all breaks down. Below that, we have Winnie the Pooh, Star Wars, Disney Princess, Anpanman, which is also from Japan, Harry Potter in general, Barbie, the Marvel Cinematic Universe, Call of Duty, Batman, Hello Kitty. Some things you may be familiar with, some things you may not be. But there's a lot of things that are worth money. And a lot of things from Disney are specifically their own thing, like Frozen's its own franchise and it's listed differently as opposed to like one Disney. If Disney, I'm sure if all the Disney stuff was like added together, they'd dominate the list. But in terms of like individual franchise, yeah, Pokemon's pretty big. Pokemon came out in the U.S. around the time I was actually in elementary school, to kind of date myself. So I've basically been playing on and off for a while. Haven't played anything really since Sword and Shield because I've been busy. But I played quite a bit of Pokemon. And so I figured might as well do something fun with file reading rather than just coming up with like a random spreadsheet or something. So for some of you, this will make a lot of sense. And for some of you, this is just random data. Which is good because, you'll be working with random data from time to time that you don't necessarily have a full context on, but that's pretty cool. But that's pretty good. So what exactly is this file that I put on your computer? Again, it's a CSV file. And what does that mean? It's comma separated value, right? It might as well open up in a, you could open it up in, say, like Excel and you'd see a spreadsheet. So the first line of this file, so this is a fairly large file. In fact, it's basically a file of what I'm assuming is all the new Pokemon 2, but basically all the Pokemon and their various forms that have been released through the years. Because some Pokemon have come out with variants and stuff like that. But regardless, every unique Pokemon is kind of over here. We've got an ID, which is like a number to identify them with. Their name, what the name of the Pokemon is. Form, again, some Pokemon, they have different forms depending on, how versions have gone on. So like the Mega forms from from not Diamond, but I think it was Sun and Moon that came out of. Forms based on a time of day, forms based on region and that kind of stuff. What type they are. Pokemon generally, and it says type 1 and type 2. Pokemon have two types. What part of the appeal of the game is that it's a giant game of rock, paper, scissors, where basically some Pokemon have a better matchup against other types of Pokemon. So basically it's that combination that allows you to do kind of prevail in that game of rock, paper, scissors. And then finally, stats. It is an RPG, role-playing game, and you can't have a role-playing game without stats, essentially. You can, but it ends up being very difficult. So The higher the number, the better the stat. Pokemon have 5 stats. You have, no, sorry, 6 stats. Yeah, 6 stats. Your attack, your HP, in other words, how much of a beating a Pokemon can take. Attack and defense, basically how hard it hits and how tough it can stand up to a physical hit. Special attack and special defense, those are for things like shooting fire or electricity at enemies and how well it resists being hit with fire or electricity in general. So some Pokemon very good at punching stuff, less good at shooting energy balls at people. And likewise, some Pokemon are really good at resisting, those energy attacks and those mental attacks, but give them a physical attack and they'll fold like aluminum foil. And then speed, which is used to figure out which Pokemon is faster than another. Generally, the higher a stat, the better. There's some weird stuff shenanigans you can do to change up stats and make lower stats better. But in general, the higher the stat, the better. So we had all these HP, attack, defense, speed. Total is basically the sum of all of the stats, and that gives you kind of a relative idea of the strength of Pokemon. Something with a strength of around, and it's very uncommon to see something like, let's see, is there anything with a strength of 700? I think, yeah. Pokemon with around a strength of 700 is kind of ridiculously powerful. We see only like 12 entries in there. But the reason I have this is that we can ask some questions from this file. We can iterate over this file and we can ask some questions about it, such as which Pokemon has the highest attack, which Pokemon has the highest defense, which one has the highest combination of attack and defense, what is the average HP of a Pokemon, this last number is this thing called generation, which basically, the first batch of games came out for the original Game Boy. Let's see, and then I think the next batch came out for the Game Boy Color. That was Gold and Silver. That came out that one kind of also came out for Game Boy, but it was a new series. And then, I think Gen 3 was where we started getting that on the Game Boy Advance. But basically it's kind of the progression of the series as it went up. So, again, we can go, but I figured this would be more interesting to parse than, say, something else. And also, it's a very large file. Again, how many lines did it have? It had over 1,000 lines. So it's a rather large file, which makes it good kind of for processing because it's easier, because you'll have an easier time using Python rather than trying to figure out manually. So again, what you want to do is just kind of make sure you can open it like there. Now, by default, when we open a file, we open it in read mode. A lot of time, and for years, and you'll see me do this like forever, I add in a second argument, R over here, just to explicitly say, hey, this is a file I am reading. You don't have to open it like this. It kind of assumes it's going to be in read mode. But I like to say explicitly, hey, I'm reading this file. This is a file, and I'm opening it in read mode. There's 2 other modes, and you don't want to use them right now. The 2 other modes are, you can guess one of them. If there's a read mode, what's another mode? Right. There's a write mode. Right? There's reading file, and then one for writing a file. That would be a W. And then the other mode, and you don't want to use this because this writes a new file. So if I ran this would overwrite the file the Pokemon file I'm currently reading, which is, basically it would delete it. And then finally but basically if you needed to keep rewriting files, this is useful. And then there's append, which is you open up a file that already exists and add on to it. But in general, for the most part, you're going to be reading. On the So on the second exam, which again, we don't know when that is, but it's going to be sometime after we do, but it's going to include Monte Carlo, and we aren't at Monte Carlo yet. So, but you can definitely assume that one of the questions on the exam will be something along the lines of, hey, here, suppose you have a CSV file that's formatted like this. So I'm not going to give you all the data. I'm just going to say, this is what the data kind of looks like. Find, the average of a column. So one year, what I've done is that, so one question I've asked, and I'll give it, and it comes out in the practice exam when I give that, is here's a file of temperatures in Philadelphia. So and the columns are the date, the high temperature, and the low temperature. Write 3 different small programs, or write, get me 3 answers, which is, what is the day with the highest high? What is the day with the lowest low? And what is the average high temperature? So just kind of parsing through that. That's definitely a kind of question that you'd expect for file reading. Another kind of question that I typically ask is something along the lines of, here's a CSV file with a bunch of numbers. They're just kind of unsorted, whatever. Give me the sum of all the numbers that are divisible by 2. So something rather boring, but you can expect a question like that on the second exam and on the final exam, because that is, but as we'll see, it's not too hard. And with a lot of these questions that are bigger, I typically give you a rubric, like here are some point, like 3 points for opening the file. Well, we know how to do that. We say open, file name. We can do read mode. We can leave that off. That's fine. I like to leave it on. And I can say the file. This is the computer's representation of the file. And then then we actually need to physically read the file. Now we learned 3 ways to do that. There's read lines, and a for loop. And depending on the circumstance, it may be easier to do one over the other. But in this case, with the file being one giant CSV file, doing read is actually not going to be very useful. Instead, what I'm going to do is I'm going to say, here's our rows, and it's equal to the file dot read lines. I find it's underscore, undercase. And I find this way to be kind of really useful. And the reason for this is because when we're dealing with a large file, this allows me to print out a subset. So to prove that we've read it, let's go ahead and print the first 100 rows. Rows from row 0 up to, but not including 100, so that's the first 100 rows. And this allows me to see that, hey, here's the first 100 rows. Goes all the way up to Kingler. So let's go ahead. So everybody sees that basically that this allows us to read these files. Great. So next, let's go ahead and see what we can do with this file now. So now that we have rows, we can iterate over it. One thing that we will want to do, and one thing you're going to need to do on your homework, is that the top line is a legend, right? This top line, the top of this file is, this legend over here, right? The ID, it tells you what the data is, but it doesn't actually contain any data itself. So if I'm trying to read numbers to figure out which Pokemon has the highest HP, and I read the first line and try to convert it into an integer, that's going to fail. So in other words, I kind of want to skip that first line. And the reason, and that's the other reason I do read lines, because it allows me to skip that first line. So what I'll do is I'll say for line in rows from 1 all the way to the end. So I'm going to skip all everything that's not that first line. Make sense? And now I can go through and, print that line just to kind of show that it works. And it goes through and it prints. It shouldn't take too long because, again, there's only 1,000 lines. But again, it's going through. Now that we have a line, now that we are going through lines one at a time, that means we can address them individually and start going through them individually. Okay? So let's go ahead and give ourselves a task. Let's go ahead and figure out what the Pokemon with the highest base HP is. Okay? That's this over here, the highest base HP. Okay? So in order to do this, we got to parse the line. And now, if we look through this, every single line, every single row, so the text file is just a giant string, and what we've done is that we've just split up that string into multiple strings. It's automatically done that for us by this. But what we've got is we've got to just basically, like, the first line we'll be looking at is this one, which is just one giant string. The second line is this, which is another giant string. The third line is this, which is another giant string. Okay? So in order to get any useful information out of it, right, we need to be smart about how we do things. We can't just simply say, okay, go to like this character and read these 3 characters from the string because every line has a different length, right? And Pokemon have different names. The ID number is different. The length of the Type 1 and Type 2 is different, so that can make things a bit difficult. So instead what we need to do is that we need to split this up in a much more useful way, and the way we'll do that is by using the split function. What does that look like? Well, let's go ahead and print it out before we start playing with it. Print line.split. This is where, so split has been mentioned before, but this is where split really comes in handy when we're dealing with CSV files. So if we see, before I run it, I noticed something. I forgot to close that parenthesis. So if we see that, let's see. You know what? Let's go ahead and terminate this. Instead, again, we'll keep it simple by just simply going over the first 10 lines. Okay, just keep it simple so we can see it all. Okay? So what does the split function do? Rather than printing out the string as one thing, here, what we'll do is I'll print out, let's go ahead and just show print line, and then I'll print out line.split. So here, let's see, print, just close that. Now I can run it. So here I've printed out the line, which is what the string actually is, and line.split. So line over here is just one giant string, but when we have line.string, notice that it's in a list. And we've got the string 1, we've got the string Bulbasaur, the string empty space, the string grass. Now notice that there are commas here, but these commas are part of the string, and these commas are separating values in a list. It's kind of subtle, hard to see here, but that's the difference between the commas. Okay? But the idea here is that we split it up. Also, why is there a space here and not here? Because when we printed out the 1, it had a new line after it. So it printed out a new line and then went into the next line over here. So split allows us to work with things. So let's go ahead and say, let's go ahead and store this in a variable and show what I mean. Parts is equal to line.split. And let's go ahead and print out parts parts index 1, which should be the Pokemon name. Oh, actually need to print it out. So here I printed out the line, and then I just printed out argument 1, which 0, 1. So we got Bulbasaur, Ivysaur, Venusaur, Charmander, Charmeleon, Charizard, Squirtle, Wartortle, Blastoise. Awesome. Okay. So again, splitting allows us to really kind of make it easy to parse through these things. So now we can go through and kind of get the important parts we need. So we've split it up into parts, and I find it easy sometimes to really just kind of take the parts, and if I'm going to be using these a lot rather than trying to remember, oh, what's the name, I'll just put down, okay, I know that name is equal to parts 0. Is there parts 1? Not 0. And then we've got over here, so we've got 0, 1. So this is the form if there's one, type 1, type 2, total stats, HP. So 0, 1, 2, 3, 4, 5, 6. Why do I know that? Because, again, from the legend, we can print out parts from the legend 0, 1, 2, 3, 4, 5, 6. So index 6 will give us the HP. Everybody following so far? HP is equal to parts 6. Now I said we're trying to find the Pokemon that has the highest HP stat, which means what? If I want to do a comparison, here, print name and print HP, type name, which tells me what type it is, type HP. I'm going to delete this line so you don't have to frantically copy it down. If I print out the name and the stat, it tells me I've got a string and a string, right? It splits it when you split something. It splits something. It splits a. It splits. I'm sorry. When you split a string, it splits the string into a list of strings. So we took a giant string, split it up into lists. Sorry, into a list of strings, and then we took every string in that list of strings and turned it into a list of strings. Right? The file itself was a giant string that we turned into a list of string, and then everything in that list we also turned into a list of string. It sounds complicated when I say it like that, but honestly, if you think about it as we're just narrowing our focus down from the entire file to a line to a field, it suddenly makes a lot more sense. We're just narrowing what we can address more easily. So anyway, with that, we can let's go and make this more useful for us. HP is an integer, so we'll go ahead and convert it right there. And now it says, great, now we're printing out an integer. Now we're ready to do a comparison. We can say, highest HP name. This is the Pokemon with the highest HP name. And the highest HP, which is the highest HP we found so far, we'll say that is negative 20, because Pokemon can't have a negative HP value, I don't think, unless something's gone horribly wrong. So now what we can do is we can say, okay, we'll write out we can remove our print statements, and we can say something along the lines of, if HP is greater than the highest HP I found so far, print, well, I'll go ahead and swap them. So I'll say, well, if that is the, if the HP is the highest HP I've seen so far, I'm going to say, hey, that should be our new highest HP. This is a very common thing you're going to see, where we're trying to find the biggest thing. And what you do to try to find the biggest thing is you iterate through all the things that you're comparing. Okay? And you keep track of what the biggest one was. If your new value is bigger than the biggest one you've seen, right, then we set that value to be the new value for the highest one you've seen. Now, why did I set it to negative 20? There's two kind of strategies you can do with that. The first is to basically, if you're trying to find the biggest value, the first thing I typically do is set it to basically a known unrealistic low value, so that the first item will automatically become the biggest thing we've already seen. This isn't always feasible, though, because you don't always know what you're iterating over. The other thing you could do is you can do something along the lines of this: highest HP is equal to that, and you can say if highest HP equals the empty string. Over here, what we'll do is we'll say, hey, if it's something we haven't seen before, then that's our first time we've seen something, so we'll say highest HP equal to. And you can do it more efficiently when we're iterating things over things that are not files. You can just assume the first value you see is the highest value. But for me, I like to set it to like a known value. Like if we're only dealing with positive values, I'll set it to a negative value to just initialize it. So so we look at every HP. If that value is bigger than the highest number of HP, hit points, then we set that to be the new one. Next, we say, to keep track of who that is, we say highest HP name is equal to highest HP. Sorry, not highest HP, but we set that equal to name. And then if I wanted to, I can, and then at the end, once we're done with this loop, we'll say print the highest HP, and actually let's do the name first. So we can print out the name, highest HP name, and highest HP. Okay. And we can print it out, and we'll say that of these, and it says Venusaur. Now, everybody who's played Pokemon knows that Venusaur doesn't have the highest HP in the game. It's probably something, hopefully it's still something like Blissey. But the reason that is because we were only iterating over a small part of the file, right? We were only iterating over lines 1 through 10. Why were we iterating through only lines 1 through 10? Well, we wanted to keep it small, and if we iterate over Y1, if we iterate over all the lines, right, then we're reading over the legend, which means we try to convert the legend HP, right? We can try to convert the string HP into a string. Where's that coming from? This. We're trying to convert this into an integer, not a string. Okay? So that's why we skipped the first line. And then so that's why we had 1 here. And then we had the 10 over here just to keep it small. We don't need that anymore because we were reading a lot of values and printing out a lot of values, and we didn't want it to take forever. So now, though, we're just printing out 1, and we see Blissey at 255. 255, why? Because 255 is the highest value a single unsigned byte can have. It is, basically, it's in binary, it's this, which is all ones, which is 2 to the 8th plus 2 to the 7th plus 2 to the 6th plus 2 to the 5th all the way down to, not 2 to the 8th, 2 to the 7th, which is 128 plus 64 plus 32 plus 16 and so on and so forth all the way down to 1. Add it all together and you get 255. It's the highest value. That's the highest value for an 8-bit number. Because remember, this game was programmed in, for the Game Boy. And so bytes were kind of your biggest stat you could have there. Okay. Now, now, first off, a couple of things just to make sure you're keeping track. Why is this outside of the loop? It's outside of the loop because these values need to exist and persist outside of the loop. We need to use them outside of the loop, so they're outside of the loop. Otherwise, if they were inside the loop, we'd be declaring them anew every single time. This print statement is outside of the loop because we only want the final answer. If it was inside the loop, we'd just simply print out every time. We'd be basically printing it out every time And a more useful thing, if it was indented, would be over here, where if it was inside the if statement, which would just simply print out when it was updated. Oh, Pidgeot has a higher base HP than Venusaur. Interesting. Okay. So we can figure that out. Another thing we could do, though, is that what if there's a tie? We could simply say, hey, if HP is equal to the, let's see, if HP is equal to the highest HP, let's see if that works. We'll probably get some duplicates here, but print, we can print out that value if we get any, so we can see if there's anything that's actually going to match what Blissey has. Nope, Blissey is the highest. Okay, cool. Good to know. All right. So, also sometimes, let's see, one other thing we could do, this is perfectly fine for doing this, but one other thing we could do is there's nothing stopping us from using what you may have seen, which is a tuple, for storing these values. So I could do something like this. And basically I could store two variables in one by putting them in parentheses like this. So -20 and empty string. What does that do for me? Well, now over here what I'll do is I will store that, and then what I'll do is I'll just simply, and now I only have to print out one variable. Make sense? So let's see how that works. This is completely unnecessary, but let's see. Oh, greater than is not supported. If HP 0. Let's go ahead and should be name HP here we go. So here basically I combined them into one variable like this. And I said, hey, if the second variable is greater than, if HP is, give me 1 second, if HP is greater than the value I see in there, there we go. It basically allows me to keep that. It's unnecessary to do it like that, but I find it to be useful sometimes. Okay, so let's go ahead and now maybe try something like finding the highest, sorry, not the highest HP, but the average HP of Pokemon. Okay, what is the average value? Yes?
I'm getting a different Pokemon.
Which Pokemon?
Mewtwo.
Mewtwo? What's its value?
It says Mewtwo, Mega Mewtwo, 190.
190. So over here it means that something's not updating correctly, or you're not reading the entire file, because 255 is greater than 190. I'm going to move on to another problem though. So this will be here for reference. It's probably just something different in the way you coded it. So let's go ahead and figure out what the average is. So again, how do we figure out what an average is? It's the sum of all the values that we're going to be reading divided by the number of values we read. So that's two things we need to keep track of, right? As we're reading the file, we need to keep track of two things. Num Pokemon, the number of Pokemon we've read, and then the total HP of all Pokemon combined. So what we're going to do is that we are going, and so I'm just going to the reason I commented this out, even though I could use this, I want to get, once again, rewrite this like from the beginning so that you can follow along. So what I'm going to do is I'm going to, for every line in our row, in the rows that we read, except for the very first one, we're going to read that row. So num Pokemon plus equals 1. And what we're going to do is we're going to do line.split Technically, we can put this at the bottom. Doesn't matter where it goes. Line.split. What are we splitting on? We're splitting on commas because it's comma-separated values. Don't forget to put a string around that like I just did. So it's line.split, and this gives me our fields or parts. You can call it fields, you can call it parts, you can call it whatever you want. I'm going to go ahead and call it parts because that's 5 letters as opposed to 6 for fields. Okay, and here we're just trying to figure out what the average is. So all we care about is the HP. We don't care about the names. So which value is which is the HP? Well, again, if we went through this file, right? Which I closed, which is silly. If we go through our file and counted it manually, we've got 0, 1, 2, 3, 4, 5, 6. HP is column 6. Remember, we start at 0, so HP is equal to parts 6. And remember, we want to convert that into an integer because otherwise if we don't, we're going to try to add strings together, and that's going to give us and while we can do that, when we try to divide, that's going to give us a concatenation error. So here, we simply add up total HP is equal to plus equals the HP. And then we can find out what the then we can print out what the average is by saying the total HP divided by the num Pokemon. Okay? Which is, so the average value for the average HP of Pokemon is 70.88. So let's go ahead and have some fun with this, okay? Okay, so let's do this. Okay. Option. So let's go ahead and grab this again. Sorry, we're going to go ahead and grab this part, copy it out, and I'm just going to comment out this part again because that's what we need to do. Comment out region. There we go. So let's go ahead and read this again. And let's go ahead and now try to do something a bit more complicated. Let's go ahead and find the buffest Pokemon. Okay, what do I mean by that? Okay, buffest val and buffest name is equal to, so buffest val is equal to 0, buffest name is equal to whatever. So what is going to, okay, we're going to define buffest as highest, the buffest Pokemon is the one that has the highest combination of attack, defense, and HP. Now, why? Well, Blissey is, Blissey is great and all. It's got the highest HP, but that's a weird kind of, it's a weird kind of thing that I do not know why this Pokemon is just an absolute tank of a Pokemon. Why they decided that this cute thing is just an absolute unit when it comes to taking hits. But when it comes down to attack and defense, its stats are actually terrible. So it's definitely not the strongest out there. Whereas a combination of attack, defense, and HP might give us a better kind of value as to what might be actually really physically strong. So let's go ahead and figure that out. And I'm doing this because I don't know what the answer to this one is, And also, even if you're a Pokemon fan, you probably don't know off the top of your head. So let's go ahead and figure that out. So parts line.split HP, so we know that HP is 6. And then for the other values, attack and defense are right next to it, so 8 and 9. Sorry, so HP is column 7, although this is counting by 1, so it's 6, 7, 8, respectively. So attack is equal to int parts, copy, paste. Defense is equal to parts. And then we just simply go through and don't forget to change those. And let's go ahead and just simply create a value called buff, which is equal to HP plus attack plus defense. And then and then we do the same thing because we're trying to find the most of something. If buff is greater than the buffest val, okay, then we'll say buffest, then that our new highest value is going to be that value we just read. So again, if our value is greater than if what we read is bigger than the biggest thing we've seen so far, that becomes the newest big value. And then we should keep track of who that is. Okay, name was, and if we and just off the top of my head, name was you had ID and then you had name. Parts is equal to 1. And again, it's better to just kind of do it like this rather than try to memorize it. And then we can print out what that is. Print name, and then how much that is. Name and, not name, but buffest name and buffest val. Okay. And that would be Eternatus at 620. Not really surprised considering that's like a boss Pokemon. It's not really fair, is it? Let's go ahead and see. Now, what would I find more interesting is keeping track of the 10, like the top 10. But to calculate that is actually a bit more difficult. Because you'd have to keep track of, you can either, like if you wanted to do the top 3, you could keep them in a list and then you could update the list accordingly, but it would be, it's kind of a nuisance to do that. Why not? Let's do it that way. So let's go ahead and do that. Buffest is equal to, let's go ahead and figure out what the 3 biggest are. So let's see. Boom. Come up. Boom. Come up. Boom. So what did I just do? I made 3 empty lists in there, and we will create the name and value, and we're going to just do that a few times. We want to do that 3 times to keep track of the... Wait, what did I just do? Okay, so just keep a... So to keep you on your toes, right? So, right, if you do ha times 3, it gives you ha ha ha, right? If I were to give you 1, 2, 3, and then I multiply that by 3. So if I take a list and I multiply it, it doesn't multiply the value, right? It doesn't do 3. It doesn't do 3, 6, 9. It gives me what's going to be consistent with doing it with the strings as well, which is 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So what I did over here is basically I've got myself. Oh, that's definitely not going to work. So what I'm going to do is instead I will. Yeah, that's not going to work because I want to keep them separated. Oh. Yeah. Yeah, well, this won't work. I'll just simply keep them separated like that, though. So what I'm doing is I'm going to have 3 separate values. Remember how earlier I had tuples to keep things, track of multiple things? here I'm going to keep track of the 3 buffest Pokemon. And what I need to do as a result is I'm going to modify this. So we're going to keep track of the top 3. Okay? And I'm going to do this with by taking advantage of basically some list operations here. I'm going to cheat and make it easier. What you could do is you can so there's a couple different ways we could do it. We can use list operations to do this. We could do by replacement. I think I'll do it by replacement. That's probably going to be the easiest for us. So, okay. So, while we're calculating our Pokemon, we're going to go ahead and we'll say our strongest, since this is easy enough, I'll say our strongest is equal to, we can do it manually, like this, since we're doing 3, and then I'll make it more general. So our strongest is equal to buffest 0, the thing at the top of the list. Then we'll have next strongest, or we'll do second strongest is equal to buffest 1. Sorry, I'm throwing together a complete pedagogical thing on the fly because it's actually a very interesting topic. And then third strongest is equal to buffest 3. And it'll play into what we're going to be learning next, which is dictionaries, which are so much better for dealing with this. Not 3, but 2. Okay? And so what we're going to say is that we're going to make an if-else statement. Okay? Because we're trying to keep track of the 3 here. So we'll say if buff is, so here I'm going to do if buff is greater than the strongest, and then each of these has 2 values. It has the name, and then just like over here, it has the name, and then it has the field, the value, so like that. And the reason I've done it like this is because it's a lot easier to do than doing this. Or at least it's a lot easier to read than doing this. This means the first entry in there, right? The first thing in the list, index 0 in this, and then the 1 means index 1 in that thing, right? A lot easier to, so if I do this, 1, 2, right, 3. If I do this, okay, then this is a lot, how to say. So if I've got this, let me go ahead and save this as A, so A, B, C, just to kind of give you some values, right? If I say L, 0, it gives me the first thing in this list, A1. If I do L1, it gives me the second thing, B2. If I go L2, it gives me the third thing. If I go L3, right, there is no third field in that list, right? First field, second field, third field. This is a nested list, right? But you can think of each list as an item. It's a list of lists. So this is the first item, the second item, the third item. Now, when I'm dealing with this in Python, I love to break it out like this, so it's easy to deal with. But there's nothing stopping me from basically operating it as kind of a 2-dimensional thing with rows and columns. Although it's not exact. Yeah, and to show what I mean, I can say like print, for a row in L, print row. Right? There's nothing stopping me from viewing it as a 2-dimensional thing like this. Other than the fact that it's rendered flat, and then at least visually for me, I have to draw it out like that. So instead, I view it as like a list. Here's the first thing, second thing, third thing. And then I can do something along the lines of list 2, entry 1, and entry 1 in that. And that is 0, 1, 2. So that's this part. This is that part. And then item 1 in this is this. And so anyway, this looks complicated and annoying, right? Terrible. Right? So rather than doing that nonsense, what am I going to do? I just simply separated it out like this. This is a bit easier to read, especially for this part. So if I say if it's stronger than the strongest thing in that one, so if I'm saying it's stronger than the, and see what I'm doing over here, if it's stronger than the strongest, it is value there, then what am I going to do? I'm going to update it. I'm going to say, okay, that should be the new strongest. I'll say strongest is equal to, and I'll put it in a list, just to make it's easy, name. So I'll then swap it out, essentially. Name, and then buff. Right? And I can do that. I can say something like L, right? L2 is equal to Apple 100. And you'll see that it's A1, B2, Apple, and 100. It swaps out that item, right? Again, the fact people get freaked out because this is because you view it kind of like this. But what it is just it's just an item. I like to visualize it as like a cabinet of pull-out drawers, right? So you've got like a stack of drawers. You open it up. And inside the drawers are like the files you have to riff through. So the first number is which drawer to open up, and the second one is the folder inside that drawer that you're trying to get out. So that's a useful metaphor. And then you can layer that as deep as you need to, right? Okay, so inside, if there's 3, inside the folder is the particular paper I'm looking for, and you can abstract it like that. You rarely want to think of it in abstract like kind of dimensionality or 3D matrices. That just makes your head hurt. No. To give yourself a physical representation. Or just, avoid doing that. So if it's stronger than the strongest, great. If it's not greater than the strongest, so I'm going to say else if it's, and then I'm just going to copy this. And I'll say if it's greater than the second strongest, and then I will say if it's greater than the third strongest. Oh, actually, L if buff greater than the third strongest. I'm getting ahead of myself way too far, but you can kind of see how this works out here. If it's greater than the second strongest, we do the exact same thing over here. If it's better than the second strongest, we replace the second strongest. And then if it's greater than the third strongest, we will replace the third strongest. Okay? Okay, and so now if we do that, we can now, so if we do that, that should work, and now we can just simply print this out. So now print out Buffist over here. And let's see, it just simply gives us 1, 2, 3. So I obviously did something wrong. Buff is greater than strong. If it's greater than that, else if it's greater than the second strongest, otherwise if it's greater than the third strongest. What did I do wrong here? Buff. Sorry? The name. So I've got Buffist, right?
It seems like you're updating like the variables, but you're not actually updating the Buffist 0, Buffist 1, Buffist 2.
Oh yeah, you're right. You're right. I'm updating the variable. Silly me. That was a rookie mistake on my part. Good job, everybody. There we go. So I was replacing the variable, and if you didn't catch that, what I'm doing is that I'm replacing the variable in here, but that variable gets rewritten each time, and again, that doesn't change what's in here. I'm kind of just creating a copy of it. And then 2. Good job. That was a good unforced error. And there we go. So, Eternatus, and that's like a boss Pokemon. No surprise there. That's ridiculous. And then Groudon, I'm not surprised that it's the most buff of those because that's basically like a Pokemon representing like Earth and volcanoes and like lava itself. Groudon. Right. It's particularly. I mean, that's a particular. I mean, anybody who's played Pokemon knows that guy's a heavy hitter. So, so makes sense. And Zygarde, yeah, sure, take it. Now, so now this leads to an interesting question. So let's go ahead and I'm going to copy this. And then I'm going to go ahead and comment it all out again. Leads to a different question. What if I wanted to fight the top 10 buffest Pokemon? Right? The top 10 most buff? That suddenly becomes a slight issue here. Now we have a couple ways to go about this. Okay? And there are different varieties of overkill and kind of just different philosophies. Okay? So, and the first way is kind of just like this maximalist approach, which is that, which is like to keep track of which item it is and to sort it on that. And that requires us to look at some Python documentation, which is annoying. And the other way we can do that is we will, create 10 empty things in here. And what we'll do is that we'll make this more abstract. What do I mean by that? So let's go ahead and keep track of the 10 most buff here. And what we'll do is I'll create a list over here, and rather than trying to type it all out, I'll do for I in range. Now there's a way to make this like in one line. But what I'll do is I'll say buffest dot append, and we're going to use a lot of list functions now to help us with this. List dot append and we'll append that value that we've been putting. A placeholder for the name and a placeholder for the strength of that Pokemon. Okay? Okay, same thing applies here. For every line, we grab the name, we grab the HP, the defense, and we add them together. So what's going to change is everything over here. So let's explain what the strategy is going to be here. So rather than, going through and swapping out the values, what I'm going to do is I'm going to physically modify the list. So what I'm going to do is I'm going to iterate through every value, everything in this one. And let's see. I could pop off. So basic, which means to remove. I could remove, every time I find something that's bigger, I could remove it and then insert, which, that will work. Okay. Yeah. So that's what I'll do. So what I'll do is that, so I've got a list of things here. And what I'll do is that for every item, I'll look through all 10 entries, okay? I'll look through all 10 entries. And for each of those 10, and once I find an entry that I'm buffer than, I'm stronger than, what I'll do is I will say, hey, list, get rid of the last thing get rid of the weakest guy in this list, and then I'll insert myself into the appropriate area. Okay? How does that work? It's actually fairly straightforward. Hopefully. If it lets me do it like this, it may not let me do it. Give me a second. Can I do it that like... Hold on a second. I need to make sure I can actually do it like this. My plan may have a... My plan might have a flaw. Oh, no. It won't have a flaw. Maybe. We'll find out. For I in... Yeah, what I need to do is to use the range function. For... index in range, I'm going to just go ahead and use length of buffest in case we want to change it later. So this will go through indexes 0 through 9 in this case, right? 0 up to but not including 10. And what I'll do is I'll say that this, I'll say current is equal to, so the current thing I'm comparing to is equal to buffest dot, at that index. Make sense? Make sense to everybody? I'll say it's the buffest at that index. And let's see. And I'll say if buff is greater than the current, let's see, greater than current 1, right? What am I going to do? Okay, I want to see if I can do this by throwing things out as opposed to replacing things. So let's see if I can do that. Buff dot pop. What does pop do? It gets rid of the bottom item in the list. So here, let's go ahead and show that in action. So here I've got, let's go ahead and do list, range, 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if I do, so let's go ahead and save that actually because I need to. Okay. Let's go ahead and do 0 through 10 to make that, okay. So L is equal to this. Okay, that's an easy way to generate a list very quickly. L.pop to get rid of something on the end of it. You got rid of the 9. The very last thing in it. And then my plan is, I think, L.insert is what I need. And then I can insert an item. Let's see, 1 second. What is that? Give me 1 second. L insert, and what's this say? It says index and object just before that index. So if I can I do 200 right before, sorry, index right before index 9. Can I put 200 there? This will tell me whether or not it works. Yay, okay, great, it does work. Okay. So, yes, this will work, great. So what I'm going to do is that if I'm bigger than anything in the list, doesn't matter what it is, okay, if I'm stronger than anything in this list, then I got to get rid of the last guy in the list to make room for me, right? If I'm stronger than anything in the list, by default, I'm stronger than the last guy. We're assuming that this is going to be kept in order, and it will be, just by the way we're programming it, okay? Assume for a second that this is in order. If I'm stronger than anybody in the list, then I'm stronger than the last guy. So I get rid of the last guy in the list. Then what I need to do is that I got to push myself, and I got to insert myself rudely into the list. And what I'm going to do is I'm going to say, insert myself into the current index. So I'm going to say, hey, we're currently at, say, index 4. I want to be at index 4. So now I'm going to push myself into index 4, and what's into index 4 will now be index 5. Basically, insert allows you to push something in the middle and shove everything else over appropriately, and it handles updating everything. So index, and then what do I need to put in? Name and buff. The values that we have. And then finally, what I need to do is I'm putting in a break, because once I found that I'm stronger than something, we should stop, right? Once I found I'm stronger than something, we should stop comparing because I'm stronger. All right, let's see if this worked. Not buff. Okay, so let's see, buffest. So now, buffest. Here we go. And there we go. So now we will have, and so now we've got the top 10. Oh, okay. So that's interesting. Aha, I see what happened last time we replaced somebody. So in fact, we've got Eternatus, Aggron, Groudon, because there was a tie there, Zygarde, Steelix, Melmetal, Calyrex, Tyranitar, Slacking, and Avalugg. And for any of you who play Pokemon, this kind of, you're kind of nodding and going, okay, yeah, that's right. That makes sense. Slacking, of course, is really big. He's super lazy Pokemon. Really strong stats, ridiculously strong stats, except he skips every other turn because he's lazy. Hilarious to play with against people who've never played against him. But as soon as you come up against somebody who's prepared to deal with him, he's trivial to beat. So yeah. So again, so notice that we went from a more kind of, okay, let's keep track of this top 3, and now we can do this for any arbitrary amount. We can do it for the top 20 by changing it to this. We only need to change the variable in one place. So first off, if you're doing something that's going to, that you could change the variable for, and suddenly, the size of what you're dealing with changes, it's a very good strategy to remember, oh, maybe I should just have it be changeable in only one place. Okay? And I did that by just saying, hey, I'm not going to put 20 here or 10 here. I'm just going to go by the length of the list, so that if I change it later, I don't have to change it in multiple places. Because when you're in a multi-hundred line program, that becomes a pain. An even better approach would be would be something like this, num to track. So when we put something in big caps like that by default, that's what in other languages, we kind of use that to denote what's called a final variable. In other programming languages like Python, like Java, you can there's a word called final, and you would say final int I is equal to, this is a common one, final double pi is equal to 3.14159, and what the final does, okay, and in other programming languages, in Python, you can just do this. In other programming languages, you have to say the type and then what it is the first time you're going to use it. Why? It's just the way programming languages work to be a bit more efficient with memory. And then final, that's something that other programming languages have, like Java. And what that does is actually really cool. What it does is that it prevents you from accidentally changing the variable. The value of the variable is final, unchangeable, can't change it. So, but Python, we like to be able to play loose with the rules. Still, regardless, it's really good to be able to kind of note that this is num to track is equal to 20, and then I just have to change it in one place again. And so we can now keep track of the top 20. And there you go. Why is Groudon on there twice, you might be asking? Because Groudon has multiple forms, and that's its super duper form, its mega form, and this is its regular form. I guess it's just that. He's just that good. All right. So, but this is a really good file to kind of practice on. You can find, we could say, yes?
What did you put for buffus.insert name and what?
Buffus.insert, buffus.insert name and buff. But we can do other things like this. Okay, let's go ahead and keep this. This is now easy to modify to kind of answer additional questions. This is the last thing I'll show. We could ask a question like, okay, this is for all Pokemon. But what about for just fire Pokemon? There's different types. Fire is one of the most prevalent types. A lot of people in the first game you chose Charmander because you eventually got a dragon, although it wasn't actually a dragon Pokemon. It's a fire Pokemon, even though it looks like a dragon. I'm still not letting this go, Okay, so Charizard is a fire type. So let's find out what's the buffest fire type, and we can do that very simply by saying, by creating a type 1 is equal to, and what's the field for type 1? Remember, Pokemon can have 2 types. So that's parts 3, type 2. I'm not just using the word type because type is its own command. Parts 4. And now if we only want to go over fire Pokemon, we could say if type 1 equals 5, and it's capital F fire, or type 2 equals fire. So if either is fire, then and only then will we want to run through this for loop. So if we only want to do this for loop if we only want to do this for loop for fire Pokemon, we just simply do this. I said this. It doesn't let me. There we go. Hit tab and then indent it. Or you can select, if you're working in idle, you can just simply hit format and then indent region over here. And now this will only select fire Pokemon. Or it should. Type 1 is equal to fire, type 2 is equal to fire. What did I mess up here? Let's see. Type 1 is equal to fire. Let's see. So 0, 1, 2, 3, 4. What am I missing up? What did I miss? Okay. So, what did I miss? If type 1 is equal to fire or type 2 is equal to fire. Did I miss some? Oh! That's silly. Anybody want to know what it is? Well, it does, and for some Pokemon, but it wouldn't matter for there. What it is that this here. Let me print out type 1 for you to see in action. Type 1. Everything is surrounded by quotations, by the quotation marks. So what we'll do over here is I'm going to use another keyword for cleaning strings that I love to use, which is strip. And that says simply get rid of everything that's around. Get rid of any preceding or succeeding. So anything before or after that is a quotation mark, essentially. That should work now. And if it doesn't, well, I'll just change I have over here. There we go. And now this is only for and now we've got this covered only for fire Pokemon. Yes.
Could you just use single quote marks?
Yes, I could use just single quote marks on this to change it to check like this, but I also found I thought it was a bit more valuable to talk about. So other programming languages don't have that capability. So so it was more valuable to talk about something that is doable in other programming languages, which is stripping, which is to get rid of those characters. But yes, there's nothing stopping you from just not having the strip and instead matching the quotation instead. All right, so let's go ahead and, you know what? I will go ahead and, since we're already dealing with this as an announcement, rather than posting it on Discord, I will just simply dump it right here onto there, so as a reply to the announcement, so you'll have it easy reference to it. Make sense? All right. I hope you have a really good weekend. Today is supposed to be really nice, and then it's supposed to be not as nice the next couple days. So go ahead and take advantage of that.